Welcome to Physics 30 Prep Fast Track, lesson number 10. We're dealing with two-dimensional motion. So when motion is just back and forth or up and down, we say it is one-dimensional. So if an object is just moving north and south but not east or west, that would be one-dimensional. If an object has motion that is back and forth and also up and down at the same time, it could be considered two-dimensional. Much of motion is actually three-dimensional, but we'll not study that here. So from an earlier example, if we walked 3 meters north and 7 meters east, then to find the overall displacement of this two-dimensional motion, you would use two tools, and those are Pythagoras and trigonometry. Pythagoras, c squared is equal to a squared plus b squared. Here we have the two sides of a right-angled triangle. And of course, 3 squared plus 7 squared gives us 58. And the resultant is going to be the square root of 58, or 7.62 meters. So even though you walked a total of 10 meters, the resultant is only 7.62 from where you start to where you end up. So that's the magnitude of the displacement. But also we need the magnitude and the direction of the motion. And so to find that angle, we use some basic trigonometry. Usually the sine, cosine, or tan will suffice. And so in this case, the tangent of theta is equal to the opposite over adjacent, 7 over 3, 2.33. When you go inverse tan, you get 66.8 degrees. And of course that means 66.8 degrees to the east of north. We use north as our reference point, and we use how many degrees east of north. And that's a good way to describe motion. So our final answer, 7.62 meters at 66.8 degrees east of north. So the three types of two-dimensional motion we really want to focus on are projectile motion, that is when an object is thrown into the air and influenced by gravity. So it has two components of velocity: horizontal motion. The horizontal motion, of course, is not affected by gravity, whereas the vertical motion is affected. We'll look at three different situations using two-dimensional projectile motion. The first one is when an object is rolled off a table or shot horizontally from the top of a cliff, or the old Wile E. Coyote running off the edge of a cliff. He doesn't actually go straight out and then straight down. He actually goes through a parabola. All right, cartoon physics are a little different. Anyways, that's one scenario. Another one is if you were kicking a soccer ball or hitting a golf ball or any kind of object that is projected from a level field at an angle and lands a certain distance away. Horizontally, it has a certain type of motion. Vertically, it's affected by gravity. And finally, a tough type of question would be an object projected from a height at an angle, lands in a lower position, or perhaps even in a higher position if you were shooting from the down or from the ocean. Let's say here you have a cannon that's shooting at a ship down here. Well, the ship could actually be also shooting up at the village or the encampment on the top of this cliff. They would certainly be at a disadvantage, but it could still be that kind of problem. So those are the three different scenarios we can run into. So the first question, example, is a ball is projected horizontally at 5 meters per second from the top of a 2.5 meter shelf and hits the ground below. The two questions we would ask are, how long was the ball in the air? And the reason we want to know how long the ball is in the air so that we can figure out how far from the base of the shelf does the ball land. And so one of the best methods of solving these, not the only one, but most methods will include a separation of both types of motion. So what we do is we say, all right, let's put the horizontal motion on one side of the solution and deal with everything horizontally, and then let's put the vertical on the other side. Now the reason we do that is because these two types of motion, horizontal and vertical, are independent of each other. One is affected by gravity, the other isn't. So horizontally we can use the equation velocity or speed is equal to d over t. There is no acceleration and therefore acceleration isn't a factor. So v is equal to d over t. However, vertically, because acceleration of gravity is 9.81, we have to consider that. So we used our 4 kinematic expressions that we were introduced to earlier on. And so we might find it helpful to separate the two motions. And one is horizontal, and of course the time of flight, both horizontally and vertically, is the same. Now in this case, if we can find the time of flight, then we can also find the time of flight horizontally. So vertically, if we find the time of flight, we use that same time horizontally. And there is enough information on the vertical side to solve for that time of flight. We have the initial velocity is 0. Now the reason it's 0 and not 5 is because vertically it's not moving up or down when it leaves that shelf. It's moving horizontally, but it has no vertical velocity, so we say that's 0. Any horizontal object has a 0 velocity vertically. But of course, as soon as it leaves the edge of the shelf, it starts to accelerate and pick up speed. So using this information, we have the initial velocity 0, acceleration 9.81, displacement is going to be 2.5 meters. From the top to the bottom of the shelf is 2.5 meters. So that's the vertical displacement. So having 3 variables, we can figure out the 4th. And then once we know that time of flight, we can then use that solution in the first part to solve for d, because d, of course, is equal to speed times time. Since v is equal to d over t, displacement or distance is equal to v times t. And that's our basic solution. So let's maybe go through that. So the basic idea here is that in one dimension, vertical, there is downward acceleration of 9.81 meters per second squared, but in the other dimension, horizontally, there is no acceleration. Now, we, of course, are ignoring the effects of air friction. All right? As you get more sophisticated in physics, you'll start to include things like friction and so on. So the horizontal motion is uniform motion, so we use v is equal to d over t, distance is equal to speed times time. So we know the speed already is 5 meters per second. What is the time of flight? So we get the time of flight by using these 4 variables. Initial velocity, as we said, was 0. Acceleration is negative 9.81. Displacement is negative 2.5. And the time is unknown. So we take our basic formula, the one that doesn't include VF. Notice there's no mention of VF here. So we look through our 4 kinematic expressions, and one of them doesn't have VF, and that is this equation. D is equal to VIT plus 1/2 AT squared. Since VI is equal to 0, then D is equal to 1/2 AT squared. And if we manipulate that for T squared, we get 2D over A. And this is the practice that you need to do, choosing the correct formula, manipulating that formula for your unknown. Then you just substitute. 2 times negative 2.5 divided by negative 9.81, that is A, and you get 0.5097 seconds squared. Remember, it's not seconds, seconds squared. To find T, you have to take the square root of that, and you get 0.714 seconds. That's the time of flight. And since it's the time of flight vertically, it's also the time of flight horizontally. So with the time of flight now known, we can solve for the horizontal displacement. And remember that d is equal to v times t. The velocity is 5 meters per second. The time is 0.714 seconds. That's the time of flight, or the hang time if you like. And you get a horizontal distance of 3.57 meters. That's an excellent kind of question, and that's the type you'll see quite a bit of in this course, and of course even in Physics 30 you might run into a question like this. And we'll look at the other 2 types of motion in the following lessons.